Up next is the Crest VS900 professional power amplifier. This is an amp that will put out 450 watts per channel into 4 ohms, 225 watts per channel into 8 ohms, and it'll do it all day long. Professional power. Let's check it out. This is the beast that you guys have been waiting to see. This amplifier can run in bridged or stereo mode. There's a little switch down here. If you push it in, it's in bridge mode for mono, and if you remove it, it's in stereo mode, so it's in the stereo position. Before I make up some cables and connect this, let's crack the top and take a look inside this unit. This thing is very heavy. It weighs about 45 pounds. It's a beast, and this unit's going to have some pretty good size iron in it, I'm sure. A couple things I want to do to this unit besides do an initial inspection. I want to modify the fan, because this unit has a 2-speed fan and the slow speed runs all the time, but it's still relatively loud, much louder than you would want on an amplifier for home use. So I'm going to change the resistors, or the resistor, in the fan circuit for the slow speed. Put a little bit larger resistor in. It's an AC fan that will slow the fan down but still provide air. Air is drawn in the front and it's blown out the sides over the heat sink, so there should be a heat sink running across here with the power supply. Alright, what else comes off on this? I think the top cover. Oh, I guess there's more screws in the side that need to come out on this one. In order to lift the top cover off, it looks like you got another half a dozen screws to remove, so let's get the screw gun out now. Take those ones out. Okay, one small pile of screws later, and the top cover should lift off or slide back. I guess it slides back on this one because it's kind of it lifts and slides, maybe. That's free. There we go. There's the beast. I think blowing the dust out is the first order of business for this one. Here's the transistors on the top. As you can see, there are extra mounting holes for additional transistors. That would be for the next model up, which is even more powerful than this one. So they use the same board. This will be one channel, like left channel or channel 1, channel 2, and then there'll be more complementary transistors on the bottom side of this massive heatsink. This is our power supply. Made in USA. What size are these caps? These are 9500 microfarad, 85 volt. This would be for the low rail power supply. First things first, let's dust it off. Now, one thing that you won't see a lot of in an amplifier like this is capacitors. There are not many, because this is a direct coupled amplifier. So all the solid state transistor stages are directly coupled to each other. So you see a bunch of transistors in here, but actually very few capacitors. There's what, one, let me count them up here, what I can see. 1, 2, 3, 4, 5, 6. So there's only about 6 of them on that board, and some filters on the other board back here, and some capacitors in the control, like for the indicators, metering as they call it, and the fan speed selector, which is right over here. This is where our fan speed is selected. This will be the resistor that determines the low speed for the fan, and then there's a triac that kicks in that switches it to high speed when it's required. And that would depend on many factors. It would depend on how much power is being drawn and the temperature. There'll be temperature sensors that if the temperature starts to get too high, it'll switch the speed up to blow more air onto the heatsink. Of course, this one here has a massive heatsink, as you can see. Power transformers over here, power supplies over here. The fan is going to blow air this direction, and it's going to be channeled through these aluminum fins and out to the vents on the side. So very efficient cooling, and of course cool air is also going to be drawn over the transformer to cool the transformer as well. Capacitors here made in USA, look to be really high quality. The board itself looks to be extremely high quality as well. So I'm going to turn this on and see if it turns on. Obviously I can't really plug this into my my isolation transformer. I guess I could put it on my variac through the dim bulb to power it up, but I'm going to plug it straight into power. Okay, first time firing this unit up. Actually, the fan's not that loud. You know, and you can hear it, but it's not a super loud fan, and it's up and running. Now, if I changed out this resistor, this is the AC resistor on the fan. If I changed out that resistor to a larger value resistor, obviously it's going to run the fan a little slower. Right now, let's just check the voltage to the fan. I'll just measure across the resistor. I don't know which side's going to the fan and which side is not. Fan plugs in right here. So I'll measure to ground and just see what type of voltage I get here. 72 volts to ground. Obviously, when I kick it up, see, it goes to the higher voltage first and then drops down. So this side here, this is the low side. The AC would go into the bottom, into the other side of this. This is the side here. If I put another resistor in series with this one, that would drop the speed of that fan a bit, or just change out the resistor. Could do that. It's going to see where it's connected here on the board. I mean, it's not that noticeable, but in a quiet room you'd hear it, so it might be nicer just to slow it down just a little more while still providing enough airflow to cool these massive power transistors. According to the schematic, I've got the print for this one. It's 330 at 10 watts is the resistor, wherever I did with it. This is the schematic here. And here is this is the circuit. So how this works, this is our fan. So our power comes in, it's AC, coming off the AC plug. Our power comes into the fan. Here's the fan plug. And our neutral goes straight through, and our hot line comes through, and it goes through this large resistor, which is always supplying power to it. There's a triac, track 1, which the two main terminals will bypass that resistor. And it is controlled from this optocoupler over here. The optocoupler turns on which provides some feedback through the gate to turn on the triac and turn the fan up to high speed. And the way it's wired, of course, is that if the resistor were to go open for any reason, it wouldn't try to turn the triac on, right? It wouldn't turn on at all, because there'd be nothing here nothing to trip it. But the optocoupler is what controls it. And if we look down on the board, here's the circuit right here. So we have our optocoupler right there, and this is our triac, and this is the resistor. So if I put another larger resistor in series with this resistor, I can slow down the fan. Now, unfortunately, I don't have the size of resistor that I would like to put in there. I'm just going to put a bigger one in just for shits and giggles, to see how much slower. All I've got in that largest size is 680 ohm, which is probably going to make this fan turn pretty slow. But let's just see how slow it will turn. So I'll just unsolder the lead for this resistor that's going to the side here, if I can get it hot enough. And we'll just clip this other resistor in series just to see how slow it will turn the fan. It's probably going to be too slow, but it can still kick to the high speed, right? Now my resistor is separate. Make sure I didn't splash any solder down there. I don't think so. Looks like it's clean. Now I can clip on this other resistor, and we'll see how much slower the fan runs than how it's running now. If there's still enough airflow, then this might work. Right, I've clipped the resistor on. Okay, and it's on. The fan is turning. Ooh, it's actually turning fairly. It's got some airflow. Not a lot of airflow, but there's airflow there, that's for sure. It's quite quiet. I should shut off some of the other things that make noise in here just so I can hear how quiet it is. So the side that's going to the fan is the outside case here. This is the side that's going to right down through power to rail, to the rail, AC power. If I clip my resistor over here to the switched side, now I'm only going through the 680 ohm resistor over here, the 20 watt 680 ohm resistor, and that'll of course increase my fan speed a little more, and that is enough, I think, enough air, and it's quiet. I'll turn off the other fan. I'll turn off the overhead fan now that the air conditioner is shut off. So now take a listen to how quiet this is. You'll hear it first start up fast, and then it'll slow down. I think I can live with that. And it's still bringing a fair bit of air that will keep this thing cool. So I just need to mount this resistor, attach it to the case, and attach the other side over to the switched terminal, and that should give me a reduced speed on the fan, which should still provide me with more than adequate cooling, because there is a fair bit of air coming over here. That should keep this unit cool enough for use in residential use without having the fan make so much noise that it becomes detracting from the music. And that's the complaint that my friend that's got the BGW, that he loves the BGWs, but he says the fan drives him absolutely crazy. And that's why with one of his BGWs, we actually pulled the fan out and put a computer fan in, just because it was so loud. It drove him absolutely crazy. One of them, the resistor had burned right out, so the fan wouldn't come on at all until it got hot, and then it would come on full power. And then it would shut right off. But it's good to have airflow going all the time. So I'm just going to reconnect this. I'm going to hook it up permanently to the circuit breaker here, and we'll figure out a place to stuff that resistor. As long as it's not touching anything, I've got the ends have been heat shrinked anyway, so should be able to attach this into here, and then we'll make up some patch cords, hook this thing up, and give it a test. I was thinking I'll solder this wire onto this case here. And I'm going to support this resistor. I'll bind it to the other resistor. Put some copper wires around here, tighten them in place to hold this up against this other resistor so it can't move, right? That way it's not going to run the risk of falling down or breaking or shorting anything out. So I'll just get some bare copper wire to wrap around there and tie it in place. As long as it doesn't touch this other wire that's still energized coming off the top, I'll put some heat shrink tubing on there or something to insulate it, just so that there's no chance of it shorting out against anything once I've got this in place and tied in place. We'll strap it. And secure it. That's one binding wire. I'll put another couple ones on here just to hold this so that it can't move. Okay, I'll now connect it to the back of the circuit breaker here, the spade. This is the switched side. So I'll pull the connector off here just momentarily. Get a bit of solder on here just so I can tag on that wire.
If you guys are wondering, that resistor was the one I bought for that tube radio that had the filament resistor in the line cord, and then I ended up modding it and using a solid state rectifier. So I had that extra 680 ohm 20 watt resistor, perfect for this application. So I just had to use it.
That should hold it. And then there's still enough meat to plug the connector on. Now when I power up the unit, I should have a reduced speed fan. Okay, power. Excellent. The voltage now going to the fan is 49 volts. See, when it first starts up, it'll start up at full power and then drop down to 49 volts. Still enough speed. There's still a fair bit of air coming off that. I can feel the air coming out the side here as it sits without it getting too noisy. Just gonna make sure that none of these wires touch against this resistor, because this resistor obviously is going to get warm. That's why it's sitting up there and tied down to the heat sink or the standoff for the other one, because these power resistors do get hot. One thing we've removed is we've removed the heat coming out of the old resistor that was actually going down against the circuit board. There's a lot more a lot more place for air to cool it. And of course the cool air is going to be passing over this resistor, which will help keep it cool anyway. It will get warm for sure. This other one actually got quite hot, but this is a 20 watt resistor, so we don't have to worry about dissipating any excessive amounts of current through here. 20 watt. The other one was a 10 watt, but we went from 330 ohms to 680. So we're going to drop a little bit more current through this one, but still it's more than enough for this application. So now I can throw this together because, to say, as far as I know, there's nothing wrong with this amplifier. I bought it as a working amp, not one that was broken. That's why I laugh when people say I got it for free. No, I didn't get this one for free. If you look up what these amplifiers go for, if you look them up on eBay and see what they've sold for, I didn't pay anywhere close to what the eBay price is on these amplifiers. I'll just say that. But it wasn't free. So I want to make this thing a long-term investment, and that's why I've gone to quieting down the fan, because a loud fan becomes annoying when you're trying to listen to music, but you need it for cooling. So I'm going to go get my preamp. I'm going to wire up. I got to make up a couple of cables. I've got myself some 1/4-inch phone plugs with right angle connectors. The reason for that is because with the cabinet on here, this unit can stand on end. Right? There's a lip on the cabinet that will stand off the input and output connectors from the floor. So it can be rack mounted, but it can also stand up. And where I'm planning on putting this, I don't have room in my cabinet for it. So I was going to stick it in behind the cabinet and just stand it up on end. And have a remote power switch to turn it on and off. Let me get the top cover back on this now that I've got this amp nice and quiet the way I want it. We'll make up some cables, I'll drag out my preamp, and then we will listen to this. So give me a minute to get the top cover on. But just before I do, I'll turn on the fan in here again. It's starting to warm up in the shop today. I'll just get another peek down at the board here. You know, some of the driver transistors are actually socketed, so they can be changed out if ever necessary. But as I say, it looks to be a really beautiful design on this board. Very high quality circuit boards. This is American manufacturing, right? This is a commercial amplifier. Crest Audio, and for those that are not aware, Crest was bought out by PV. This was their professional division. So the very same type of amplifier is sold under the PV brand, and everybody knows who PV is. They make a lot of heads for guitars, you know, amplifiers, professional amps. So these are built to very, very high standards, but they're not super expensive. Like even when they're new, they're not ridiculously expensive, but they are, you know, fairly good power. This is a Class AB. This one. There's also a Class H design. I was looking at this one here, and see, this has only got a single power supply. So there's a step-up model which has a separate board in it that's got this board, the booster, right? The booster schematic, and the booster board. Is it this one? Where is it? Or did I not bring it out with me? I thought I had it with me. But they use a high rail and a low rail, so a different transformer. But anyway, this is the booster board. Yeah, see, the schematic is shown for the V1100, and for the V900 it says emit. The VA or VS900 is the same. Emit Q18, 120, 122, and 124. That's these ones here, right? So that's these transistors here that are emitted. But there also, I believe, is another power rail on here as well, which I was just looking for the schematic for that. I thought I had it. I looked at it. I know I printed it. Grabbing the schematic there, I was pulled up a schematic and I had the crown one mixed in here. No wonder it looked different. This is the print for this one. This is the Class AB version. There is a Class H version available as well, and that is this one here. and the difference between them is the power supply, obviously. It has this booster schematic. The booster schematic has the extra transistors mounted on this board and on the other board. So it's got an extra 4 transistors. This one's got 4 transistors per complementary pair, so there's 8 transistors per output, and the next model up has 16 transistors per output, because you got 4 positive and 4 negative for each channel. And then, say, the Class H has the extra transistors, and this is the booster schematic for this. Here's the Class H high rail PCB. There'd be another board that would be mounted in here, and in addition to it having the 4 big capacitors here, it has 2 more capacitors rated at 125 volts each, which this one doesn't have, for the high voltage supply. This one's just got the single. How a Class H amplifier works, for those that are not familiar, is it's a way of increasing the efficiency without having to really build too big a power supply that wastes a lot of energy. So they have a lower voltage high current supply like this that's used for normal listening and normal amplification. But then when you get those extreme dynamics where you need more voltage, there's a second supply with capacitors that are charged up at a higher voltage, ready to go, and they're switched in with MOSFETs to raise the rail voltage instantaneously. So normally the rail voltage on this one here is, since the caps are rated at 85 volts, our rail voltage is probably about 150 volts rail to rail. I would think these are probably running around 75 to 80 volts each. What does it say on the schematic? Does it tell me what voltage I should expect to see there? It says low B plus. We can certainly measure the low B plus and see actually what it is. So here's our voltage. Here's our low B plus. So 78 volts. So we're pretty close to that 85 volt limit on the caps. So call it 79 volts. Even you want to call it 80 volts if you want. So that's 160 volts is the swing that this one has. Potential 160 volts to the speakers. The boost caps are probably running, they're 125 volt caps, they were probably running them at 120. So that gives you 240 maximum versus 160, so that the high rail for those instantaneous powers on the Class H version of this amplifier, the power could jump to up to 240 volts output. So that's the big difference between it. But this one here, with its 160 volts available on the speaker terminals, that's loud. I mean, that's a lot of power. You would never, I mean, even in a professional sound environment, you probably wouldn't need much more than that. But this is kind of overkill, especially for home use. Like, this thing will turn my speakers inside out every which way without even breaking a sweat. Put the top cover on, make sure that wire is not going to get pinched anywhere. Get it out of the way. Like that. Okay. Let's make up the connectors. I bought a couple of new connectors, shielded plugs. These are actually what people would use on a guitar. The reason I bought these ones is because it can lie flat, and that way I can stand this up on end and not have the connectors break. That's why I bought this type of connector. Alright, let's open it up. And we need to connect our shield and hot wire. These are old Monster cables, if you're wondering where these came from. I just took the ends off a couple of old Monster cables that I had, just because they're nice heavy cables. Not that I think that Monster cables are really worth what they charge for them, but I didn't pay anything for them, so I think the cable inside it is no better than anything else, to tell you guys the truth. It's cable is cable. It's just nice shielded cable. It should do the job quite nicely, I think. Alright, I got one soldered down on both sides, soldered down to the shield as well as the center. I'm going to put the insulator on here, and the back goes on and it actually squeezes the ground around on all sides. So once this goes on and the back gets screwed down onto it, it should provide an even better ground all the way around. So that's one. Let me get the other one going, and then I'll go grab my preamp and we'll try this thing out. Okay, I've got my two cables done. I've wrapped this one in black tape, not for any reason other than to indicate that it's the black connector. In this case it's blue. The other one's the red. That's the only reason why. It's just to mark it. It's got nothing to do with insulating or anything. It's just so that I know which one's which without having to trace the wires. Let me go grab my preamp. Alright, I've got my ancient old Sansui preamp connected. The output's going to the inputs on the amplifier, and my CD player or my MP3 player is plugged in. Let's turn it around and turn it on. Here we go, first test run. I've got everything set to center, loudness is set to 0. Alright, power on. I'll turn on the preamp first. Power on. And CD input. Okay, I got the volumes turned down on the back. I'm just going to turn the volumes up on the back here. I'll just shut it off while I do that. So turn the inputs up all the way. I had them set to about 50%. Okay, power back on. It works. These aren't the greatest speakers. I don't want to get too carried away because this thing could take these speakers and turn them into Swiss cheese pretty quick. Oh, that sounds good. How about the loudness control? Variable loudness control. speakers was moving off the nail. Had to go recenter before it falls down. Yeah, I had this thing rocking here for a bit and getting a little bit carried away. I had one of the speakers popping against the end of its travel. This thing could, as I say, turn these little speakers to Swiss cheese pretty easy, but my God, this thing sounds good. I don't know how good it comes over on camera, but just even with these little speakers, this thing sounds fantastic. Can't wait to hear what some good speakers sound like. Because the speakers I'm using on this, I'll show you, they're just little bookshelf speakers. They're just some dual duct JVC piece of crap speakers from a junk, very cheap mini system. That's what I'm playing on these right now. Have the bass and treble and loudness turned off too, right? Turn on the loudness for low levels. It'll bring up the bass and treble a bit. Got my little polks on now. Let's see how my polks sound. Need a little bit better speakers. Can handle a little more power too. Sounds even better still. I can hardly wait to hear this on my B&Ws. Holy crap. With these little speakers here, I can't even hear myself think that was so loud. I don't know, it's probably all distorted on camera, but this, folks, is why you need lots of reserve power. Holy crap. I'm at max power. Impressive. I don't want to do that too long with those speakers. Even though they're not, I mean, I bought these speakers, I think I paid about 250 bucks for them. I used to use them in the house until one of the cats decided to use it to mark his territory, and they started to stink. So then they got banished to the garage for testing. But holy crap, that thing is loud. As you can see, I had it just starting to hit the soft clip. So I was pushing it to full power, and this thing just sounds unbelievable. I think that about does it for this one. Thanks for watching. We'll catch you in the next one.